Today I just had to change out my water heater out of my house. This one was 14 years old. It finally gave out on me. It is a gas water heater. It runs off natural gas. It's been pretty dependable up to the past few months. And what I was told was this control unit was messed up. I've replaced the thermocoupler in it a few times over the years, and it kept getting on, but I've never seen inside one of these things other than just getting to the thermocoupler. So I figure I'll make a video and let y'all see what's inside of it too. I'm going to first start off with the control unit right here. It looks pretty straightforward to get loose. You got your lines that come from the burner assembly in the bottom that come up to it, your pallet line, your main gas line, thermocoupler, and you can also see how I've had this one. That's the oxygen depletion sensor, that if it ain't getting enough oxygen to the fire, it'll trip it out instead of it shutting off and causing a gas leak. Kind of same thing, the thermocoupler, it detects whether the pallet light is lit. If it goes out, it don't picks up that heat, it'll shut the gas off. That way you don't have a gas leak. This sensor went bad on me about a year ago, and this is the only way I could keep it running and just getting by until I could get me a new heater. I would not suggest doing this because that can be dangerous. The new hot water heaters, their control units are different than this one. They're electronically controlled. I'm not quite sure how that works, but it works the way it was explained to me. It works off of millivolts. Where that power comes from, I don't know whether it comes from somehow it generates power off the flame or what, but it has a little LED bulb that'll flash codes to you if a pallet light goes out and let you know what's wrong with it. But anyhow, I'm going to take these lines loose from the bottom of the control unit. In the back of the control unit just has a pipe there that screws into the tank. So I'm going to get this off and let y'all take a look at it. I'm going to go ahead and take out the burner assembly too. This is the burner assembly. You can see it just slides out from underneath the water heater all in one piece. You got all these lines that goes back up to your control valve. The igniter right here goes in here. That tip right there is the igniter. When you push this button, it creates an electric charge and it creates an arc in between this prong and the end of the pilot valve to light the pilot. I'm going to turn the lights out so you can see that blue arc that happens when you push this button. So that's all it is to the lighting mechanism on these type of igniters. It's a word for it, piezo or something like that is what they call this kind of lighting system. Actually, if you're sitting here lighting it and you got your hand on this wire down here, when you press it, you can feel a little bit of electric shock coming from right here. You really will feel it if you put your finger on the end of that or near that whenever you go to light it too. Let's look a little bit more at this burner assembly. This access door right here on the outside of it, this is the peephole where you can look through to see if your pallet's lit when you're trying to light the pallet valve. Over here, this sensor right here goes to the other side, and I believe that's called a oxygen depletion sensor. In the bottom of the water heater, where this sits in, up under it's these vents that brings in air to fuel this fire. Well, if a lot of debris and stuff gets caught up in them vents and it can't get the oxygen to feed this, instead of it trying to burn and then cut off because it's not getting the oxygen, the fire can't burn and cause a gas leak, this will shut the pilot light off. This one on mine went bad about a year or so ago, so I just had took these two wires that comes from it. Here on the control valve, it's got two prongs right here. They just plug one on each side like that, and of course this center part of it is where the thermocoupler end screws into. Here are the other ends that goes to the control valve. This one right here, usually it'll be a copper wire like that. Has that threaded bushing right there. That part goes into the control valve. This is called a thermocoupler. The other end of it comes out right here. You got your pilot valve here and your thermocoupler there. What that does is detect the heat coming off the pilot, and it feeds it back to the control box. If this doesn't pick up that there's a flame here, it kicks off the gas in the control unit to keep from a gas leak happening. A lot of times, and this one you can see too, you start seeing that rust and corrosion and all on them. Over time these get burned out, and periodically you have to replace them, which is pretty easy to replace. You saw previously how I pulled the unit out. You do the same thing, and basically this thermocoupler, it's got a clip right there that holds it. It goes into the back down in there. A lot of times you can just pull them through. But this one's being stubborn. All that on top of the burner is just from burnt debris that gets up under there. Just like what I said before, your new hot water heaters are coming with filters that go around the bottom of the tank to keep from debris getting sucked up in there. And all this is burnt ash from dust and debris that the draft has brought up through there. Yeah, through some enforced motivation, you can get that thermocoupler to pull on out of that keeper, and it just slides on out. These rivets on it, these ribs on it, help hold it in that keeper. This one got kind of dirty and stuff, and made it hard to get out. But when you were changing one of these, you really ain't got to worry about messing up the end of it. You can force it and stuff because you're going to replace it anyways. Once that's out, you got this block here that serves as holding the lines through in between this outside door and coming into the burner assembly. And you can pop these bushings out. Yeah, it's got this keeper right here. There we go. There's that little keeper for that block. And these blocks will come out through the outside. When you're changing that thermocoupler out, if you ever have to do one, you gotta get them blocks out of the way. And that's all it is to that. See, that's metal right there. I could have thought I remembered it was plastic, but yeah, it's metal. That goes in the scrap metal bin. See, once you got that out of the way, you can pull that thermocoupler straight out. We'll just wind this up for now. Set that to the side. Also, through that block, your igniter goes through it, which the igniter is threaded. Well, actually riveted. It's got riveted in this block right here that holds that igniter in place. I don't know how hard that is to come out. I ain't never tried it. That screw went somewhere, but that'll go in the trash bin too. Alright, taking that screw out, you can get the rest of this little assembly out. You got this threaded part right here, which is for the pallet valve. Wonder if that comes off. Yep. That line comes loose from that pallet valve. It looks like the rest of this was made to stay together and maybe change out in a pair if it had to be repaired. As far as I know, with this older water heater, can't get parts for it no more unless you go searching on the internet and take a gamble on one of them, maybe a used one or something. But I knew my tank had a lot of rust in it. It was only a matter of time before it started leaking. There's the igniter right there, which I might say that igniter may come in handy one day. You can use things like that for making potato guns and stuff. This is the pilot valve gas line. Still seems like it's in pretty good shape. May can be used for something, may go into scrap bin. What I may end up doing is just cutting right here to get this assembly free. So I think I'm just going to hang on to that. Never know what that could come in handy for. These wires too, they got good ends on them. See if you're ever needing a jumper wire to jump power on this 2 different terminals. You use them for that. About the only thing left of the burner assembly is the burner itself. The gas flows through this, the biggest line that leads to it, be the biggest line on the outside of the assembly. Flows in there, flows up. It has these flutes in here that the gas comes out with the pilot light sitting right here. Once that gas starts coming out, it lights that gas all the way around, and that's what heats your water until it goes out on you, which I was lucky. Mine lasted 14 years. It could have been a whole lot worse. I think the new one I put in only has a 6-year warranty, and it will probably stop about a month after that warranty is up. Next, we had the control valve right here. This is on the older style. The new ones you get now are completely different than this. Everything's just made out of plastic. To me, I think it'd be better to have a metal one like this, but that's just me. The temperature dial just pulls right off. It's got a slotted keyway in it that meets with that keyway on that shaft. You can hear it when you turn it, clicking on and off for the water temperature. This is the part that was threaded into the water tank. I'm guessing that is the thermometer for the water temperature. It's got like this plastic housing over it, and it looks like there's something metal down in there. So let's get this plastic off. We'll just rip it and make a big mess. Feels almost like some sort of waterproofing. I can feel that I stirred up a lot of rust in that. Yeah, there's rust coming out of there. Let me go get a knife and cut it open. Alright, let's get down to business. There we go. There's your temperature probe, if you want to call it that. You can see that it has some sort of coating on it. You see that coating right there. But around this tip, it's a lot of rust. And you see where that coatings came off. So yeah, you can tell this had a lot of use out of it. The cap that normally went here to control pallet mode off and run mode, it broke off a long time ago. But you just move it. That was the pallet mode. You hold that button down while lighting the igniter on it to light the pallet light. On this end, that was the inlet for the natural gas. On the bottom, that was the out that went to the main burner. That went to the pallet valve, and these were your safety connections. Your thermocoupler and the oxygen depletion sensor. Let's see if we can get, I know that thread's out. Let's see if we can get it out. Huh. Well, you have like a nipple connection right there. That would have been for the thermocoupler, I'm guessing. It's got where it came in contact right there. I'm guessing these things right here reacted with the thermocoupler. Maybe it expanded when it was hot or whatnot. I'm not quite sure. But that's part of the safety system on it. Or maybe it was just to hold this part in place to ground it or something. But you see that thermocoupler probe went right there. This thing comes out the back right here. And it looks like it leads down into the control. I don't know whether it goes into this or into the box. So let's check that out too. Let's take this probe off. This screw right here was a booger. It was tight and I couldn't get it broke loose by hand, but there's a trick to that. If you got a screw like that that's really tight and this feels like it's going to start stripping the head out on it, take you a mallet, or what I did, I took these pliers right here, held the screwdriver down on there, and right on top of the screwdriver, just give it a few good whacks. What I'll do is, if there's any corrosion in them threads, it kind of, from hitting that, the vibrations kind of break up that corrosion, and then you can get your screw out. And now the screw's stuck on the end of the screwdriver. There. So, yeah. That oxygen depletion, not oxygen depletion, the thermocoupler, it is in contact with this probe right here, which this probe has a nipple on the end of it that comes into contact right here. The way I'm thinking is, this is just me thinking, is internally, when you turn the temperature up here, it controls some sort of spring which controls how easy these things move, or how much they expand or something. I think it'd be that one. That one feels like it moves. But this sits in right here, and then that probe right there is resting on that. So I'm wondering is, as this heats up, heats and cools, this pin moves in and out that controls this, which is got this pin right here, is right at the main gas valve for the burner. And right in the middle of it is a shaft where the temperature gauge goes. Alright, I can notice some sort of movement. As I turn this, that right there is going in and out slightly. So what I'm thinking, this is just me thinking, is when this gets to a certain temperature, it actually comes in contact with that grounds it out, that tells it to shut the valve off. That's about the only way I can figure out how it works. If you know exactly how this mechanism works, leave a comment down below. I would love to know. We're just getting a look at something that we ain't never seen before. I mean, that nipple right there is in there tight. I don't think anything else will move. But yeah, somehow this arm right here, this lever, controls how hot and how cold it gets. Somehow. Okay. I'm going to take, let's see, I'm going to take these screws out first. All these screws that's on this mechanism have that little safety tab that's in that Torx bit. So a lot of times you can take a screwdriver and break them out. But sometimes you can take a small drill bit, and once you hit that drill bit, it'll break it on out. Alright, I think we can work with that. I've already done these 3 up here. See, I think I missed one right here too. Yep. Alright, off camera I got the 2 screws out at the top. One of them came out easy, the other one rounded out. So I just took a drill bit and drilled it out. And part of that assembly was this little keeper arm that you had to push down to change it from like pilot to full blast. That way it would keep you from turning to the wrong setting too fast. And all that good stuff. There's a little scrap metal. Then this comes off. This is the control valve that turned it off, pilot, and on. It's a little interesting to look at it. It's got a plunger in it. I don't know if you can see that. It's got a little plunger. I guess depending on where you had this thing set at. Kind of hard to turn now. They ain't got it in something. Oh well. Yeah, that was the selector valve, and you can see down in here there's kind of a large port right there. There's 2 smaller ports right there, and I'm guessing that where there's nothing at was where it would be at in the off position. I'm guessing this thing turned to where it needed to turn to give gas to either the pilot or whatnot. So that's a little interesting. I wonder if this plunger come on out. Well, it broke out. You see the rubber part up there. I'm guessing that's a diaphragm. That goes in there to it. So take that plastic out, throw it to the side. And let's open up the main box. Perfect. See if we can get this open. Or not. There we go. Sure, it's got a seal in it. To be able to get it all the way off, we're going to have to turn it that way so that keyway is out of the way. And there we go. All kind of springs and stuff in there. So that spring's right on the back side of that. That's where the probe, the thermometer probe, made contact at. So yeah, I'm guessing this worked off springs and stuff to control the temperature of it. This heats up, it expands. When that expands to a certain amount, it hits this spring loaded part right here and it will click off. Wondering what that was for. Some sort of diaphragm or something there. Looks like it may have like a bleeder hole in it. Right there, it's got some insulation. Wonder what that's there for. Huh. There's an orifice port right there. It's got this channel ways that leads kind of over into it. I'm guessing it's for spill off or extra natural gas flowing through there. This helps catch that natural gas and run it in there and cycle it back through there. A lot of things you see in here, it makes you kind of think of a carburetor, but it ain't a carburetor, that's for darn sure. But yeah, that's pretty cool. All the little components of it on the inside of it. I'm sure there's more stuff inside that's cased together that we can't even get to. Oh, there's one more screw right there. Sometimes it uses the force of drilling it out to get the job done. You can see how that one was stuck and it rounded off the head and drilled it out. I had to drill that one out. So that stud with that spring on it is what the light, pallet light valve rode on. You hold that down to light your pallet light. So that's that orifice in that part of it. Rest of it seems like it's sealed in. This seems like it was stamped in. So basically this thing was not made to really service if you started having problems. See here where all the thermocoupler stuff went into, all that's sealed in there. It looks like that part was pressed in there after the fact. So, but it's kind of interesting to look at. I ain't never seen it before. Now it's just one more thing to do with all this stuff. Throw it in the scrap bucket. Good riddance. Oops, I almost forgot that too. Good riddance to that. Before I can get the outer casing off, I believe I'll have to remove that pressure valve and that drain valve down at the bottom. So let's do that. Here's the pressure valve right here. The only thing I can think that that's for is like a temperature sensor. It works kind of like a thermostat, and if it builds up too much heat inside the tank or too much pressure, it'll open that valve. These check valves have this little safety check on it that you can test, make sure water flows through it, and when you pull on it, you can see it moves that inside ever so slightly. The drain valve is just a plastic valve. You know, the end of it right here screws to a hose pipe. There's a bunch of gunk build up in the bottom of that one, probably years of rust and stuff. Now I'm gonna get to work on taking this outer casing off. That's where the burner assembly was. See, it sits up under here. You got the bottom of the tank and the flute that goes up through it. And here's that vent on the bottom. This is the bottom of the tank. That's that vent I was talking about that it draws air up through. Here's the bottom of it taken off. That's that chamber area. You can get a better look at the bottom of the actual tank. You see it's got that insulation between that outer casing and the tank itself. You can see there that outside casing, between the outside casing and the tank itself, it's like they insulated. This stuff's like that expanded foam. That stuff is like glued to that tank. But up under it, about an inch, is the tank itself. I finally got a hole cut in the side of this tank. I scraped back some of that insulation. You can see that metal is probably about 1/8 of an inch thick, but it's pretty hard metal. I believe these tanks are tested up to 400 PSI. You can see some rust right there. And that's understanding considering this is 14 years old. As we look inside of it, that tube going up right there in the center is the flute pipe. I believe that one at the bottom of the screen there is the water outlet. That's where the water goes, the hot water goes out to the lines. And you see there's a lot of rust and sludge in there. So even if my control was still working, sooner or later this tank would have started leaking. After a while they'll rust out and start leaking. But that's it. And you see the skin of it's peeled back. That was the top there. And there's the bottom. And that was the top, and that was the bottom. Now there's just one more thing I gotta do with all this junk. Take it to the scrap metal yard. So that's a look inside my old gas water heater. I thought it was pretty interesting to see. I hope you found this video entertaining. If you liked it, please remember to give it a thumbs up, comment, like, and subscribe to my channel. Thank you for watching.